All right, we're rolling. We are rolling. Okay, so what is our first step in a trig proof? This is example 4. We're proving. Draw a line down the middle. Okay. Your first step is for sure not to like multiply both sides by cosine, right? Divides out. We don't do that when we're proving, right? We work each side independently, and so that's kind of the purpose of that line. All right. Then we decide on which side we like to start, and we're looking for the side that has more information or is easier to break down. And of course, the obvious choice is left or right? Left. Okay. So now I'm on the left side. See, here I stand. What can we do? What'd you do, Darl? Yeah, nothing's squared, so Pythagorean identities are off limits. 1 minus sine, ooh, you so badly want to call that cosine, but it's not because it's not squared. So can you split it up? Can you say it's cosine of t over 1 minus cosine of t over sine of t? Is that legal? Can you split up denominators like that? No, no. If you do that and it feels naughty, it's for a reason. It is naughty. Can you do that on the right side though? Can you call that 1 over cosine plus sine over cosine? Yes, you can split up numerators by putting each term or any combination of terms over the entire denominator, but you can't split up denominators. Now, let's see if that helps. 1 over cosine is secant, plus sine over cosine is tangent. So yeah, we're making progress, man. But look at your left side. That's your target. And you're like, oh, it looks like I'm doing stuff, but it looks like I'm getting further away from my target. Would you agree? I mean, now we got secants and tangents when I want it to be sines and cosines. So on the right side, if I get stuck and I want to put it back in terms of sine and cosine, I would just be doing this again and getting back to where I started. So even though that's not incorrect, it is not what we want to do. So let's just put this over here and keep a record of things that successfully don't work. Okay, back to what Dara was thinking. All right, he said 1 minus sine of t. Man, it'd be great to be 1 minus sine squared. We can make it 1 minus sine squared because 1 minus sine squared is a difference of two perfect squares. And we know that we get a difference of squares when we multiply two what's together? Conjugates. So one of the legal things that we can do with an expression is to multiply by a clever form of 1, like 5 over 5. That does not change the value of the expression, but that's not the clever part. If I want to get 1 minus sine squared, and I know that that then comes from the product of two conjugates, what is the conjugate of 1 minus sine of t? 1 plus sine of t. And if I do that in the bottom, I need to do that in the top. Because now, what is 1 plus sine of t over 1 plus sine of t? 1. And what's anything times 1? Itself. Okay. Now, look what that's going to accomplish. That is going to accomplish in the denominator 1 minus sine squared, just like we wanted. So that is one reason why you want to multiply by this clever form of 1, the conjugate over the conjugate. Now, here's another insight. If you're starting on the left and the right side is your target, notice you want to end up with a 1 plus sign in the numerator. See that? Well, why not just say, I'm going to create then what I need. If I need a 1 plus sign in the numerator, let me go ahead and multiply by a 1 plus sign. But if I do it in the top, I have to do it in the bottom as well. And so that's kind of what we call a win-win. It creates what we need in the top, and it's going to eventually give us our difference of squares that we want in the bottom. All right, so now when I move down to the second line in the numerator, do I want to distribute this cosine into the 1 plus sign? No, because my target wants the 1 plus sign visible. So we're just going to leave it factored in the top. 1 plus sine of t times cosine of t. There you go. And now, Daro, what is the denominator? Cosine of t what? Squared. Good. Now, notice on your target on the right-hand side, you only want to end up with one factor of cosine. We currently have two, but mira, we have a factor of cosine in the numerator. And so what happens with one of those guys? They divide out. And we are left with, we don't need parentheses anymore in the top because there's not anything to multiply it by. 1 plus sine of t over cosine of t. And, well, it takes practice. Okay? And there are other routes. That's why we're going over strategies. You have to kind of memorize strategies. So what should we sign off with here? It's International Nose Picking Day, so let's sign off with booger. Okay? Woolly booger. My 8th grade math teacher, who is still alive, Anna Kensing's grandfather, Mr. Richard Kensing, he used to call problems that were challenging woolly boogers. And I always liked that. Woolly booger. If you eat a woolly booger, it gives you a warm fuzzy inside. Yeah. Now, what? Oh, broccoli. Yeah. Green cauliflower. You could also equivalently have started on the right side, because notice there is an opportunity again to multiply by a conjugate. We have 1 plus sign now in the numerator. What is the conjugate of 1 plus sign? 1 minus sign. So notice if I do that in the top and bottom, that's equal to 1. So not only is that going to give me the product of two conjugates in the numerator, which leads to a difference of squares, right? 1 minus sine squared. But notice also, if the left side then is your target, you want a 1 minus sine in the denominator. So let's multiply by 1 minus sine in the denominator to create what we need. So win, once again. So that gives you 1 minus sine. You leave it factored. Oops. Cosine of t times 1 minus sine of t. And then the top is cosine squared. Let's get rid of the woolly. Just leave it as booger. Cosine squared of t over cosine of t times 1 minus sine of t. And now, of course, that divides out with one of those. And we're left with cosine of t over 1 minus sine of t. And that would have been the top left. So it works on either side. So this is what you need to train yourself to look for now. Two things. First of all, if you ever see a trig function plus or minus 1, or 1 plus or minus a trig function, whether it's sine or cosine, secant, tangent, cosecant, you have the option of multiplying by the conjugate over the conjugate. And that will always set up a difference of squares, which then could always lead to a Pythagorean substitution. So that's a strategy. Another strategy is you can always use the other side, your target, and create what you need. Okay, if you need something in the numerator or the denominator, multiply by that over itself. That's equivalent to 1. And then work with the rest of the stuff and see if it doesn't work out for you. BK? Burger King?
Yes.
Well, that'd be a great restaurant, right? Burger King. All right. Any other comments or questions on this one? Did anyone get it on their own without my guidance as a warm-up? No? Okay. Well, let's go ahead and summarize then. Another strategy. Multiply by a clever form of 1. Conjugate over the conjugate. If you ever see 1 plus or minus any trig function, or a trig function plus or minus 1, multiplied by the conjugate of the conjugate to set up, like I said, a difference of squares and then a Pythagorean substitution. When you do that, expand the conjugates, but leave the other side factored. Okay, so something divides out. And let's go ahead and add this other strategy here. Create what you need. Create what you need. And I'll just say what you need divided by what you need. Okay, it has to be equal to 1. All right, so that's another strategy. And it kind of works out well on both the numerator and the denominator. Okay? All right, any other comments or questions? Picnic day. Picnic day. Do people still picnic? Yes. With the blanket and the basket and the ants? Yeah? Okay. All right. Example 5. Prove the following identity. Those instructions are getting old. There we go. We have theta now instead of t or x. And I'm gonna leave it to you to jump in on it. Okay. It's always good that you wrestle with it first. You get acquainted with it, and you get intimate with it. Yeah. You see it. You smell it. You taste it. You hear it. You get all your senses involved. It becomes a part of you. When you're done with the problem, you don't want to leave it. Goodbyes are hard. Don't do nothing. Do something. Yeah, do a little something on both sides. Remember? As Diamond Rio said in the song, you start walking your way, and I'll start walking mine. We'll meet in the middle, neath the old Georgia pine. We gain a lot of ground because we both give a little. There ain't no road too long when we meet in the middle. There you go. That's the song. Yeah. So you work a little bit on the left, you work a little bit on the right, and in the end, when the bottoms are the same, you're done. There you go. All right, who's got it? Anyone got it? I'll come take a peek. Mm-hmm. Don't forget your variables. It's real easy to leave your variables off, right? Cosecant. You need theta of theta of theta. You will lose points. When we ultimately take the test over this, you'll have a little bit of a safety net. The first part will be like proof 4 out of 5. So if you can't do all 5, no big deal. If you do all 5, it's bonus. But they're worth 2 checks apiece. The first check is, did you take a step in the correct direction? Check. And then the second check is, did you complete the proof? So if you actually complete the proof, but you leave off a variable, like a theta or an x, you're losing one of your checks, even though it's correct. So details are important. Variables. And here's another thing that I saw, and I see it a lot, and I don't know why, but let's say you have tangent of x. You know that sine over cosine? I see a lot of people do this, sine over cosine, of x. Is that right? I don't even know what that is. Yeah, that's not sine of x over cosine x, so don't do that. All right, let's see what y'all did here. Which side do you want to start on? They both kind of look ugly. The left, all right? You see now that there's an opportunity here to multiply by the conjugate. So again, that's just an option. That is not like when you see that automatically do that, but it certainly is an option. So let's try it. Let's just see if that works. 1 minus cosine of theta, 1 minus cosine of theta. So now in the denominator, we're going to get 1 minus cosine squared of theta. And I'm just kind of looking ahead. I'm not worried about the numerator. That's going to lead us to a sine squared. Is that going to be beneficial? Look at your target on the right. I think so, because we want to end up with a factor of cosecant squared in the numerator. And what's the reciprocal of sine squared? Cosecant squared, right? So if you have a factor of sine squared in the bottom, you could bring it to the top and call it cosecant squared. Or use the reciprocal identity. That's 1 over cosecant squared, state change, flip. So I think it's going to work. I think it's going to be good. So let's go ahead and then focus on the numerator. Do we want to distribute? Well, maybe not at first, right? That's kind of what I just said, because usually we want something to divide out. But when we do that, is this sine squared going to divide out with the secant like in the previous problem? No. In fact, we want a secant minus 1. So in this case, since nothing is going to divide out, let's go ahead and distribute and see what happens. Secant times 1 is secant minus, what is cosine times secant? 1. Why? They're reciprocals of each other. If you don't see that right away, you could put cosine times secant and then call cosine 1 over secant or call secant 1 over cosine, and you'll see that they divide out. But it's very handy if you realize cosine and secant are reciprocals, and anything times its reciprocal is 1. So what's sine times cosecant? 1. What's secant times cosine? 1. What's tangent times cotangent? 1. They come straight from the reciprocal identities. Well, how's that looking now? That's looking good. So on the next line, you could go actually straight to the final answer if you want. Okay? A factor of sine squared in the denominator is equivalent to its reciprocal in the numerator and vice versa, if it's a factor. Now, if you're not comfortable with that, and I can understand why, remember that when in doubt, do not leave it out. Sine squared is 1 over cosecant squared. So there's a trig substitution. And now I have a complex fraction. So stay, change division to multiplication, and flip, and you get cosecant squared. And is that what we have on the right side? Yeah. Now at any point, you also could have jumped over to the right side and started working over there. That would have worked as well. Nifty. Nifty thrifty. Sifty. Wifty. Hey, if you put this over 1, is there an opportunity, just thinking out loud here, could we multiply by the conjugate of secant of theta minus 1? Sure. That could be secant of theta plus 1 over secant of theta plus 1. So it doesn't always have to be just sine and cosine. If you ever see 1 plus or minus a trig function or a trig function plus or minus 1, that is an option that you have. Okay, and it will work out. It may be a little more scenic, but it should work. So anyway, I won't do that one. You could do that if you want later on. All right. Any comments or questions on this one? Anyone see it a different way? It makes sense when I do it. It'll soon make sense when you do it, because you are going to practice, and practice. Yeah. But you do have to know the strategies, okay? The strategies are just clever ways to get from point A to point B. But once you know the strategies, it's not really clever anymore. It's just a tool in your toolbox, belt, bag, wherever you keep your tools. Yeah.
So if you like halfway through on one side and you go halfway through on the other side and the ends match, like on a test with that stuff.
Sure. Let's say I got stuck right there, and I'm like, jump to the other side. Cosecant squared is 1 over sine squared times secant of theta minus 1 in parentheses. That's really the same as over 1. So if I multiply straight across, I get secant theta minus 1, sine squared, and they're different colors, but they're the same. And so I'm like, I am gifted and special. Yeah, that's it. You've completed the proof. So to answer your question, yes.
Like if that was on a test.
Yeah, that's perfectly fine. Absolutely. Okay, now if you want to hang with like the power hitters, like if you went to a math party or something, they would be like, yo, you should try to do it all on one side. And you're like, I'm out of here. It's not my kind of party. Um, all you have to do is like from here, put this line. This line would go right here, and then this line would go right here. Because really, remember what we're doing when we do these proofs is we are creating this logical sequence or loop. You could jump in anywhere and go clockwise or counterclockwise, and all the steps are equivalent to each other. Okay? Yeah. Kind of neato mosquito. Yeah, what if this was like locker room talk at halftime? All right, we need to do better. We need to come over here. We need to get this guy over here blocking that. You're like, Coach, what does all that mean? That's our game plan. Right? Oof. Instead of X's and O's, you're using secants and thetas. Oh. All right. And remember, you guys are gifted and special. Go out there and win. All right. So, yet another strategy. Do any quote unquote obvious math. Right? Multiply through, expand, factor, combine like terms, divide out common factors. Do any obvious math, such as distributing, all that good stuff, etc. Okay. Sweet. Example 6. Comments or questions before we move on? Guess what the instructions are in example 6? The following identity. All right. Here we go. What the heck is that variable? It's not theta.
That's omega.
Not quite omega. Bless you. O. Phi. It's phi. Yeah, it's phi. Now, if you don't like phi, what can you do? Change it. I don't like you. It's almost like satisfying. You draw next to it. I don't like you, phi. 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 You're Xing them out, and now you have yourself a variable called X. So let's just do that. We'll work with X. Okay. On your marks, get sets, goes. On your own. Y'all can do this one. Please do this one from start to finish without me. You can do it. Y'all are gifted and y'all are special. Bless you. Bless you all. And to all a good night. People used to go to sleep in kerchiefs and hats and caps, right? Yeah, with Mama in her kerchief and I in my cap. The big long ones, you know. How comfortable is that? Not. Ah, there you go. With Notability, you can actually get rid of phi altogether. Hmm. Hmm. Raise your hand when you get it, and I'll come have a look, see. You know that phrase, I'll have a look-see? Look-see? Growing up, I was the guy that always thought that cats were females and dogs were boys. We've had that conversation. So whenever I heard that phrase, "Hey, I'll have a look-see," I thought it was just like someone being cute, right? Like, I'll have a little look-see at your paper or whatever. But that's not what the phrase is. It's not look-see. It's not them trying to be cute. It's I will have a look-see. That's what it is. So anyway, I'll have a look-see. And it's not as fun anymore because they're not trying to be cute. I always thought it was like playful. But it's look see. So anyway, the more you know. I will come over to your desk and have a look see. A look see cito. That's playful. Someone's got it. You're getting it. 1 minus. Okay. Yeah. All right. Sweet. And then, yeah. Boom. And what's going to happen with your cotangent squareds? See ya. Wouldn't want to be ya. You stuck? Can I do it this way? I can't see that way. I don't know how you work like that. Oops. Um, okay. You are missing some parentheses. Big time. Yeah, that needs to be in parentheses. So nothing divides out there. I don't know why you did that. But that's 1 minus cosine. What's the whole purpose of doing that? It's to set up a difference of squares in the bottom. What is 1 minus cosecant squared?
That's what I'm not getting. I don't know how you do
Oh, well, write out the identities, right? You have them memorized? Write them up here. 1 plus cotangent squared of x equals cosecant squared of x. So what would be 1 minus cosecant squared? It would be negative cotangent squared. And then your cotangent squareds would divide out. Okay? It's okay to write an identity off to the side so that you can kind of manipulate it to see what it could be equivalent to. All right? That's perfectly fine. But you do it off to the side. That's your bench work, right? And then the problem itself is your product, your project. All right, I'll catch up with y'all. Someone guide me. Which side to start? Do what? Anyone? Left side. Okay, do what over here? Conjugate. There you go. There's an opportunity. We have 1 plus cosecant. Now remember, when you multiply by the conjugate, the purpose of that is to set up a difference of squares, which will then lead to a Pythagorean substitution. Okay? Now, you should know from baby pid number 2 that there is a way to relate cosecant squared to cotangent squared, right? So that's going to work. It's going to work, okay? So 1 minus cosecant and 1 minus cosecant of x. Now, in the bottom, we get 1 minus cosecant squared of x. Perfect. In the top, we are going to leave it factored. Now, if you did it like that, would you get full credit? Look at my numerator. Something's missing. Parentheses. And that's going to cost you a check if you don't have those. Okay, now, what is 1 minus cosecant squared? That's where you're like, yeah, let's make sure. Let's come up here to the side and write out baby pid number 2. 1 plus cotangent squared of x is equal to cosecant squared of x. So what is 1 minus cosecant squared? Well, let's see. I would need to bring the cosecant squared over here to get 1 minus cosecant squared, which means then I need to bring the cotangent over here to get what? Not cotangent squared, but what? Negative cotangent squared. Ay, caramba. Okay? So that is equal to negative cotangent squared. And I have positive cotangent squared up there times 1 minus cosecant. So that's why it's important for you to have them memorized, but also being able to manipulate them algebraically by just swinging terms from left to right. Okay, now what happens? Your cotangent squareds divide out, and we're left with a negative 1 in the bottom. Well, dividing by negative 1 is the same as multiplying by negative 1. So we're left with negative 1 minus cosecant of x. Or if you distribute the negative, you get cosecant of x minus 1. Now, you might think you're done, right? You're like, that is awesome. I simplified that down to that. But look at your target. You're like, not so quite. Yeah, maybe. Now, what can we do? Notice that on the left side, I don't think I'm going to try and keep working on the left side because I would have to build it back up to match that, right? I don't want to do that. So notice it's 2 terms. I'm going to go to the right side now where I have more information and I have 1 term. But there is some quote-unquote obvious math to do. Namely what? If I distribute, I will generate 2 terms, which is what I have on the left. So let us distribute. So I'm going to get cotangent of x times secant of x minus cotangent of x times tangent of x. Now, on that second term, what is cotangent times tangent, everybody? 1. Okay? Because those are reciprocals. Now, if you need to show another line, you could put cotangent times 1 over cotangent, or tangent times 1 over tangent. But those are reciprocals. Now, I guess that cotangent times secant must be cosecant. Can I just put cosecant here, though? No, it's obvious that cotangent times tangent is 1. Those are reciprocals. It's not obvious that cotangent times secant is cosecant. So what could we do to prove that? What is their genetic DNA composed of? Sine, cosine, and sine. So let's do that. Cotangent is cosine of x over sine of x. And secant of x is 1 over cosine of x. Ah, ha, ha, ha. What happens with your cosines? They divide out. And we are left with 1 over sine. See that? And what is 1 over sine equal to? Cosecant of x minus 1. And now the bottom left looks like the bottom right. And we're like, America. Yeah, or Merry Christmas. See that? So if you're off by a negative, you're going to be off, right? So it's so important not to just assume things. Go off to the side, write them out as you learn them, and manipulate them over here and bring them back in, okay? America, right? Carl's Jr. and Hardee's burger with a hot dog and an onion ring on it between 2 pizza slices. America with a big Ford truck. America, okay? All right, change the variables if you don't like them. That's the kernels that we're extracting. If you don't like the given variables, change them from the beginning to whatever you want. Just make sure you have them. And then work on both sides and meet in the middle, as Diamond Rio said. Okay. How much time do we have? 8 minutes? Is that enough to digest for today? You think so? Okay. Are you going to practice tonight so that you're ready for your quiz tomorrow? 1 to solve. Now, we haven't solved any in this section, so you're going to want to go back to 6.1 and look at that whole last section where we're solving equations. That includes like factoring and then splitting it up and then using the unit circle. So make sure that you practice those tonight and we'll quiz over tomorrow.